Hey everyone, it's Nick with RadView Detection. Today I'm going to be showing you the basic setup of our RadView Mk.2 here. It's going to be the same setup for the Mk.1, and we're just focusing on the real basics. So the goal of today was we're gonna get this device powered on, and we're going to be detecting radiation. We don't actually need a microcontroller for this one, but we're going to be using it for the 5-volt power supply that it has on it. We can also be hooking up a piezoelectric buzzer, so we can actually hear the clicks, kind of like a Geiger counter. And then we'll also be able to see the pulses of radiation with our breakout board right here. So first things you'll need, you're going to need a microcontroller or just a way to get 5 volts. You could use a couple AA batteries if you wanted to. A breadboard just for ease of use. We have our RadView Mk.2 right here. We've got our piezoelectric buzzer so we can hear it. A couple jumper wires, and then we'll need our mini XLR cable to connect the two. So first we'll go over the mini XLR breakout board. So as you can see here, if I can get it a little bit closer, it's got a mini XLR on the top here. And then it actually has 2 lights on it. So one of which being your power indicator, it's a green light. And then the next one being a pulse indicator, which is more of an amber color. This device has 8 total pins on it, but they're actually mirrored. So the 4 over here in order, and they actually are labeled. I'll throw a picture up on the screen so you can see better. You have your spectrum, so this is an analog value of the pulse coming in. You have your ground voltage in, so that would be like your 5 volts, and then a digital pulse. So that's a 1 or no, or 1 or 0, yes or no. Is there a pulse currently happening? And so it's exactly mirrored on the other side. So again, we have our spectrum, ground, V in, and then our digital 1 or 0 pulse pin. All right, so moving on from there, we're going to take this device. It doesn't matter what orientation you do, just keep track of it. If you don't mirror me, you might be backwards with your wiring. For me, I'm going to use the ground pin and the spectrum pin on the left side and the voltage in pin on the right side. And you can just throw that anywhere on your breadboard. I'm actually going to shift it just a little bit so we have room for the speaker. So now that that's installed, we're going to go ahead and wire it up to the microcontroller here so we can get power to it. Alright, so to get started, we're going to need 2 wires to get this project working. So we're going to have a red wire right here. This will be for our 5 volts or 3.3 volts, whatever your microcontroller supports. And the next is a black wire. This is our ground wire. So starting off, we have our ground pin is the second one in. So I'm going to do it on this side of the microcontroller, and I'll give pictures for you guys to show where to wire them up. And then I'm going to the ground of our microcontroller, and it's labeled right on the side here for me. And then the next one would be the V in, so I'm going to go right next to that pin. Let's see here. There you go, I think I got it. And we're going to go to the 5 volts of the microcontroller. Let's see here, there we go. So you can see we have 2 wires, we have ground and V in, and we're going to test it real quick just to make sure we got things plugged in correctly. So I'm going to grab my power cord for my microcontroller right here, plug that in, and you can see we get a nice green LED on our breakout board. That says it's working. So we can go ahead and unplug that while we set up the rest. So our next step is going to be grabbing, I guess we could do, let's do the piezo buzzer first, just so we can hear right when we plug in the detector. So we're going to take this, the piezo buzzer has a positive side, it's labeled with a little plus. We want that to be on our digital pulse side. So again, there's a little digital pulse symbol on here. We're going to go between that and ground. You don't need to do this to view that LED, but just for the video, it'll be a bit easier to show you guys. I'm going to go ahead and plug that in. That'll probably be good enough. I think it's in there good enough. Not a ton of space there. And so now we can take our mini XLR male headers, and we're going to go ahead and plug those in, just like that. You can hear a click. And we're going to grab the other side, go into our RadView detector, just like that. And now I can set that down there, and we're going to plug in our microcontroller. And as you can see, right off the bat, you can hear the clicks. You might be able to see the LED blinking. It's usually pretty fast for the cameras. Let's see if I can zoom in on it for you guys. No, you can't see it. It's too fast for the camera to see, but the human eye can see it just fine. And then we can actually use that to detect radiation. So here I have a europium source. You can hear the radiation counts go up already. And we can take this. You might be able to see that LED glowing a little bit now. You can actually detect it. So that is the most basic setup of our RadView detector. Again, all we did was we took a our mini XLR breakout board, connected a positive negative wire to it, and then plugged in our RadView with a piezo speaker, so now we can hear when it detects radiation. Alright everyone, this has been RadView Nick. Thanks for watching. Have a nice day.